Hey, this is Tom from Inspiration Modeworks, and thank you for watching this week's shop update series. We are up to episode 18. First off, I wanted to apologize. I didn't get an episode out last week. As many of you know, I have some back issues that I'm dealing with, and that had me sidelined for the better part of well, really all of last week. I was completely out. I spent a day at the VA hospital, but most of the time I was actually flat out on my back, laying down and staying off my feet and trying to get better. This week, what I decided to do, since I couldn't really do a whole lot in the shop, was to do a short video on a product called OnShape. And so it's a CAD program, or actually CAD web application that you can use. So I did post some pictures. Let me see if I'll bring them in here so you guys can see what I'm talking about. I did a quick drawing, and I made a part that it's kind of like the bezel for a security camera, right? So it's a little stainless steel nut that gets screwed on for an outdoors security camera. It was an interesting project to work on, but the first thing that I needed to do before I did anything was get a good drawing on it, and so that's what I did, and I'll take you through those steps. So here we go. Sit back and enjoy the ride. Thank you.
Okay, before we get started in today's project, I want to talk a little bit about parametric modeling and what that is. For those of you who have done some drawing in the past, like for me, I started doing technical drawing. Gosh, it was almost 20 years ago now. It was AutoCAD. I want to say it was version 12, and I actually got it on, I think it was 15 or 20 floppy disks, if that tells you anything. So really what we're talking about is the difference between two-dimensional versus three-dimensional drawing. And in two-dimensional drawing, everything's flat. You have to do a lot of calculation to figure out, in an isometric view or a side view. Sorry, kind of a what's the right word? Oblique view of it. Isometric would be an oblique view, right? What things would look like. With parametric modeling, it's much simpler. You really can use a cross-section, two-dimensional sketch, and then extrude that into three-dimensional views. So what kind of software is out there to do that? And personally, I still do things with pen and paper sometimes, or pencil and paper sometimes. I've been using Solidworks now for about the past year. There's also tools like Fusion 360. Both of these are professional level tools. They can be kind of expensive. There's also SketchUp, which is free unless you get the pro version. Tinkercad, free, or you can get their pro version, and it's like $10 a month, right, for Tinkercad. So there's a lot of different ones out there. I want to say FreeCAD is out there. There's open source versions, but in general, you've got lots of options out there, whether you're a beginner or you are an experienced professional. Today, we're going to use OnShape. And OnShape, and this has been going in the background here, OnShape is a web-based parametric modeling tool, and its founders were some of the people who founded Solidworks. It's really interesting, and Randy Richards and I have gone back and forth on this a little bit. So Randy, I hope you don't mind. I'm going to show a little bit of what you were working on the other day. But anyways, let's take a look at it. You can look, the website's right here, onshape.com. I'm going to go ahead, we'll go to My Documents. I've signed in already. And what's nice about OnShape is it's got both free versions and pro versions, right? So you can see plan free. Your free version gives you 5 active private documents, right? The pro version gives you unlimited. In this case, I've got 1 active document and 2 inactive documents. Now what's nice about this is, you can have 5 active, but you can turn them on and off, right? So for someone like me who's not doing tons of work, the free version works out pretty well, because effectively I'm going to be working on probably whatever project I'm doing that day, and I can turn stuff off when I'm not using it. The other nice part about this is, as you can see, modified and owned by Randy. Right? So let's turn this one back on. There's a clamp in here that Randy has shared with me in a view-only mode. Now you can also collaborate on these things, and you can work live on these things, but this one's view-only. But I can also remove myself from it. You can also make a copy and work on it yourself if you want to make a copy of it. I'm going to turn this back off for right now, because what we're going to focus on today is this this camera mounting nut. And I posted some pictures on social media about this nut. It's already made, but this was the drawing I did. And I did this drawing to calculate this angle here that I was going to need for that chamfer. All I knew were some basic measurements, that this through hole needed to be 47/64, so this comes out to be 0.734. I needed to have an 1/8 inch land here. Overall height was 1/4 inch, and I needed an 1/8 inch on the side here. The first attempt I did at doing this, as you can see in the features here, is I made a sketch. It shows all these holes, or all the circles. I did some extrusion in there to pop things up. I did the helix. I did all kinds of stuff, really. But it was not the right way to do it, frankly. I was stumbling through this because I'm still, as someone who started on two-dimensional kind of stuff in CAD, I'm still struggling with this sometimes. But let's go back and let's walk through the process of drawing this part. So I'm going to create a new part, and I'm going to call this the camera mounting nut version 2. Now, there is version control built in. Right? How about this? Better design. Okay. We're going to open the new document, and it's going to be a private document. Okay. So there it is. It's a private document, and there's nothing in here yet. Now, there is version control built in, so you can go back and work on different saved versions. But in this case, we're doing it a better way. What we're going to do is we're going to think of this as a cross section of the nut itself. So I'm going to pretend I'm looking at it from the front view. Right? So for you 2D guys, think about this as your front view. And so we're going to create a new sketch on the front plane. But I'm going to right click now, just so you know. I'm right clicking, and I'm going to view normal to sketch plane. All right, so now it looks like I'm looking at this part straight on. And we'll zoom in a little bit. And let's just make some lines. Right? So I know the radius, starting from the origin, the radius of that through hole is 0.734, or sorry, the diameter is 0.734, which gives me a radius of 0.367. So let's just pretend there's our radius. And then from here we'll go the rest of the way out to the outer edge of the, it's an 1.5 inch round bar that we're using, 303 stainless, in case anyone was interested. So there's the rest of that. We know it's going to go up about 1/8 of an inch. It's going to go on this taper, not all the way to this end, but we're going to go on a taper, right? And then we're going to go, there's that 1/8 inch land we know that needs to be part of here. And notice I bring the mouse down, it highlights, and then it'll bring me straight up, and it's going to snap to constraints, right? And then we'll close this out. And Solidworks automatically knows that it's closed. It created the solid for me. I just press the escape key, and now we're back to our normal view. Right? So just like that, I'm looking at this from half of the whole side view. The last thing we need to do, though, we know that there's going to be, let's find a center line. We'll do this just as a drawing, just as a construction note. So I'm going to select it. You notice as I get to certain places, it wants to snap to them. Right, so we'll just put that in there, and we'll press escape to tell it that it's done. And I'm going to select it and tell OnShape that we're using this as a construction line. I just want to know where the center line is of this hole. Okay? When we're done with that, and I can click the show constraints, and it's going to show all these different constraints that we put on here. Perpendicular constraints, parallel, or sorry, we're doing horizontals and verticals. So it shows all the constraints. I'm going to turn that off because it looks a little busy. And let's zoom in on this a little bit, and we'll start to pan over a little bit. Okay, we'll start to put known dimensions in now. So let's work with our dimensioning tool. So this is the dimensioning tool, and notice when you hover over it gives you some help. Remember, we're doing this all in a web browser, right? So really neat stuff. So we know that this leg, this is the radius of the hole. Well, as I click and as I select it, it brings up some information. I know that it is 0.734 divided by 2, right? Because I want the radius, not the diameter. There it is. Aha, automatically fixed that. Good. Let's see, we need, I know from the center point to the end, and I clicked on each one as I go, we'll bring that down, is 1.5 inches. So we'll do 1.5 inches. Alright. This part, we know the overall height is 0.250, and we know that this leg here is, oh well, it's pretty close on that one, 0.125 at the eighth inch there, and then this one is also an 1/8 inch land, which is way off right now. So as I click in here, it tells me. Now remember, you can use fractions in here. 1/8, boom, automatically changes it to 1/8. Oh, I made a mistake. Let's look at this. Let's go back. I double clicked on it. I did the whole 1.5 when really it's just the radius, not the diameter. 0.75, and that adjusts the whole drawing for me just like that. If I needed to know things, like in this case, I did this original drawing to calculate, and zoom in a little bit, I did it to calculate this this angle. I can click on these two parts, and now it automatically gives me the angle. And I used that upright because, you know, parallel lines, I don't have to put an extra drawing in there to do that. So it tells me, there's my angle, and notice it's kind of grayed out. It's because, well, it's not a constrained part, right? So that's just giving me for information as opposed to a constrained dimension. Okay, if I'm satisfied with what I've got, let's double check. I've got the right radius there, I've got the right radius here, I've got my known dimensions here, I've got my known dimension over here. Actually, let's drag this over to this side so it's all consistent. Okay, so I've got all my known dimensions, we're ready to go. I accept the sketch, and now we're back into our normal mode. Now I'm going to go into the isometric view, or that, and you've got different viewpoints here, but I'll use isometric. And so there it is. There's my drawing. I'm going to zoom in a little bit so I can see it better. And now's the fun part with parametric drawing. This is the part that I love about this, and why it makes life so easy. I'm going to select this part, that face right here, right? And remember, this is a cross section of a round part. Well, on round parts, I can revolve. So I'm going to use the revolve tool. Now notice, because I already selected the face of that sketch, it just automatically populates. But if you needed to use a different one, you could press revolve first and then select the face. Revolve axes. Well, this is why I chose the center line, right? Because I knew that's where I wanted to revolve it around. Click on that, and boom, there's our part, just like that, right? Because remember, this is a cross section, so if I had an infinite number of cross sections, each one going around, it would build this part, right? What's neat about this, though, is you can do some, you can use the revolve function to do a lot of things. You can do it just one direction. You can change the direction it goes by pressing the arrow button. You can drag it around, or you can give it a precise measurement, like 90 degrees. Right? You can make it symmetric. So as you drag it, it's going to drag both sides at the same time. Or you could do two directions in which you actually give it the two from your normal part, or where you started. We went 180, almost 186 degrees in this direction and 30 degrees in this direction. Right? But we know we need a full, full piece. I'm satisfied with that. You can change how clear that is, so you can kind of look at your transparency and see how it looks. And then select the check mark to say that you're satisfied with it. And we're almost done. Now here's where this one gets funky for me. This part, when it was modeled for me, and when I was given the dimensions, it's all imperial measurements until we get to the threading. It's a metric thread. It's M20 1.5 pitch. So we take our helix tool. We're going to select where we're going to put that. Now this has turns. We're not going to use turns. We're going to use the pitch because we know that pitch. Now notice this is in imperial measurement. Well, I know that it's a 1.5 millimeter pitch. It automatically changed that for me. Right? My default is in imperial. It calculated, but notice that when I click it again, it tells me what the actual entry was, but it just makes the change for me automatically. And the last thing in here is, where do you want your start angle to go? In this case, it's at 0 degrees, and then it comes around. You can pick where your entry point is on this. Not so important on this particular setup, but it might be in other drawings. Let's go ahead and accept that, and we'll zoom in just a little bit more so you guys can get a good view of that. And there's our part, all modeled up. And it, I was able to calculate the angle I needed to set my compound on the lathe, because I did this all manually. Sorry guys, I'm not going into any cam stuff at this point, but this is how you make it. You can, just so you know, if we select that part, you can right click on this and you can export it. So if you wanted to export it to an STL file for 3D printing, or for you wanted to import that, like I use Meshcam typically, I can take that STL file and put it right into Meshcam, and you could do this as CNC as well. So anyways, that's just a quick intro into how I made this part and OnShape. Thanks for watching, and we'll talk to you soon. Didn't mean to press that button. Sorry guys.